What we're going to do today then is be given word problems, and with those word problems, we're going to have to use logs or exponentials or using our skills from that same worksheet to solve what we need to solve for. So if we look at this first part, here's example 9. It talks about alcohol and the risk of a car accident. Fitting for prom, you guys be safe. Okay. All right. So medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. So the risk is modeled by this equation. R equals 6e to the 12.77x. And x is the blood alcohol concentration. Okay, so that's like what you talked about when you learned your took your driver's test, and they talked about like blood alcohol content of 0.08 for 21-year-olds, 0.01 for under 21-year-olds, and R is the percent of having it crash. Okay, so X is the blood alcohol content, R is the percentage of the risk. So we're doing the problem where it says what blood alcohol concentration corresponds to a 7% risk of a car accident. And it says in many states, drivers under 21 can lose their license for driving at this level. So let's put a 7, because the percent is the R, so we're putting a 7. And we're not putting a percentage, we're just putting 7 in there because it says R is given as a percentage. And equals 6e to the 12.77x. So really, after all those word problems, all that context, all we really need to do now is solve for x in that exponent. And this is a problem that we've done earlier throughout this chapter. So remember, we are going to ultimately be doing PEMDAS backwards here. So there is no addition subtraction, so we don't have to worry about that. We are going to undo the multiplication x, so we'll divide by 6. And so that would give us e to the 12.77x equals, I'm just going to leave it as 7/6. So we now want to get that x, the 12.77 and the x out of the exponent. To do that, we're going to take the log of both sides, but since this is a base of e, we're going to take the ln of both sides. Just makes things easier. If you want to take log, you could, but again, anytime you have an e as a base, ln makes it easier. Because again, what happens is the ln and the e cancel, and you're just getting that exponent of 12.77x. The right side would equal ln of 7/6. And then the last thing we need to do is divide by 12.77. So if you don't have a calculator yet, go grab one. And you would be doing ln is 7 divided by 6. Be sure to close your parentheses. And then divide that by 12.77. So we get 0.012. Now we're going to be going over the rubrics for the open-ended parts of your final exam next week. But I'll tell you right now, one of the things, and Mrs. Schultz may have said this, but one of the things on the rubric, it says that if there's a word problem, you need to not just leave your answer as 0.012, you need to make like a closing statement. Okay? So what does that 0.012 represent? 0.012 is your x, which represents the blood alcohol concentration. Okay, so you want to make a statement that kind of sums it all up. So you can say a blood alcohol concentration. You could do BAC too. So blood alcohol concentration of 0.012 creates a 7% risk. All right, so again, that's 1 full point. Like I think the rubric's at a 4 on the Harrisburg rubric. And even if you get 0.012, but don't make that statement, it's a 3 out of 4 automatically. So take your time, make that extra statement, and do it. So that's one thing we're gonna kind of keep working on these last couple of weeks. But again, as you can see, once we knew where to put the number, this wasn't anything different than what we've been doing in writing the statement. All right, so again, if I were you, I'd label this, or sorry, write this equation down. And this equation represents the percentage of adult height attained by a girl who is X years old. And it can be modeled by that equation. And it says X is the age of the girl from 5 to 15. And f of X represents the percentage of her adult height. So if you were to write anything in your notebook, or what you're writing in your notebook, I would write the equation, and I would write this is height, age, this is percentage of adult height. And then our question is saying, at what age has a girl attained 97% of her adult height? So again, the key here is we need to know where to put the 97. Where is that going to go? It's going in for fx, so it's going in for that left side. So we're going to write 97 equals 62 plus log plus 35 log of x minus 4. So again, once we did that, this is a problem that we've seen throughout this chapter. We're doing PEMDAS backwards. So we are going to be doing undoing addition, subtraction. So this 62 is what we want to get rid of first. So we're going to subtract 62. And that would give us 35 equals 35 log of x minus 4. We would want to then divide by 35. We're undoing the multiplication division. Bless you. And that would give us log of x minus 4 equals 1. Remember, this is a log of 10, log base 10. And so when we do our circle to get the x by itself, then we will make this into an exponential. We get 10 to the first equals x minus 4. And we can then add 4 and get x equals 14. So again, we want to ultimately, once we solve that, that's part of it, we want to get that extra point out of 4 and write a statement. So what this statement means, it says x is the height of the girl. So you can say when a girl is 14 years old, they would be, or she would be, 97% of her adult height. So probably, according to this model, most of you are probably fully grown already. Not totally. I guess this only works from ages 5 to 15, so that doesn't work for you guys anyway. All right. Last one final one, and then you'll have time to work on that worksheet from yesterday. All right, so This says how long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest compounded quarterly. So this is going back to the compound interest, which is a good review because that'll definitely be on your quarter test as well as your final. So remember, for compound interest, our formula is A equals P, that's our principal, times 1 plus, we take our interest rate divided by the number of compounds per year, and then we take that times the number of compounds per year times the number of years in the exponent. So we're starting with $1,000, that's going in for our principal. We want it to grow to 3,600, so where's the 3,600 going to go? Out the front. That's going to be what's going to be in our account. The 1 stays as 1. We need our interest rate as a decimal, so 8% as a decimal would be 0.08. And N is our compounds per year. If it's compounded quarterly, that's how many times per year? 4. So we're going to put 4 in for the N. We're going to put the same 4 in for the N here, and we're solving for the number of years. It says how long to the nearest tenth of a year. So we're going to keep that as T, and that's what we're solving for. Okay, so again, we're thinking there's a T in the exponent, a variable in the exponent. We're ultimately actually going to use logs. We are using that PEMDAS backward strategy right now to do that. Okay, there's no addition or subtraction I can get to. There is addition here, but that's inside the parentheses, so I can't get to that. We're going to undo multiplication division. So there's multiplication by 1,000. So we're going to divide by 1,000 first. That's going to give me 1 plus 0.08 divided by 4 to the 4t power equals 3.6. As we're working our way back to PEMDAS now, we already undid addition subtraction, we already undid multiplication division. We're now going to undo the exponent. There is a variable in the exponent, which means we have to take the log of both sides. That would force that 4t out in front, and we have 4t times log of 1 plus 0.08 divided by 4 plus 2 equals log of 3.6. So our goal is to get that t by itself. T is being multiplied by this log and is also being multiplied by 4. So we can undo multiplication with division all in one step. We're going to divide by 4 times log of 1 plus 0.08 divided by 4 on both sides. So again, as long as you're careful with your calculator, you can do this all in one step. I personally would make that fraction template bar and do log 3.6. And then on the bottom, 4 times log of 1 plus 0.08 divided by 4. And you get 16.17. I think it did say tenth of a year, so we'll say 16.2. All right, so again, we're not done until we make that little statement. What is this saying? It's saying after 16.2 years, how much is going to be in our account? 3,600. So it will take 16.2 years for the account to get to $3,600. All right, so again, goal of that is just saying, oh, we have these word problems. They may look scary, they're word problems. However, once we know where we're putting all of our numbers, it's what we've been doing this whole chapter. Okay? All right.